Alright, so let's do another example problem where we talk about other types of question that we can solve related to stereographic projection. So just a quick recall, in the first video where we did this part A where we learned how to draw a 0, 1, 0 standard stereographic projection of a cubic crystal with a 1, 0, 0 pole on the north point. Now this will go in the center, this will go in the north, but in the actual exam can absolutely have different locations. So they could give you a completely different pole on, let's say, the south point or the west point or the east point, and then you can figure things out accordingly. And then we learn how to find the angle between any two poles, and the base idea here is that those poles should lie on the same great circle, and once you have them on the same great circle, then you can count out the angle through the small grids, and then you can even analytically calculate the angle between any two plane, which is the cosine of that. So that would be the h1 k1 l1 dotted with h2 k2 l2. All right. So in this video, our focus is going to be on traces and zone axes. So this is another tricky component, but having now known how to calculate the angle between two poles, this will prove to be really helpful. So let's see how we can do that. And we'll do this all together because zone axis, to calculate zone axis of any two poles, you have to draw the trace. So the first step would be to draw the trace of these two poles, learn how to draw traces, and then once we have learned how to draw traces, then we'll see how to calculate or find the zone axis. Now, just to give you a quick rundown of the steps, the traces, we'll try to follow these steps. Whatever pole that we want to draw the trace of, we'll get that pole on the horizontal axis. We'll count 90 degrees, and then we'll mark whatever the great circle we end at 90 degrees. And same thing over here. And then to calculate the zone axis, we mark the traces of both the poles. So pole A, pole B, we follow these steps to mark the traces, and then we find the intersection point of the traces, and this becomes zone axis. Now you'll notice that the trace is a great circle, so it'll look like a arc or a curve on our stereographic projection instead of just a point. So when you are working with poles, that is like an ellipse or a triangle, basically a point in this representation. And then a trace will be marked as a great circle, whichever great circle you end up selecting. Right? So I'm gonna do some of the initial components again just to give you a quick recall of what we were doing. So all you need is a printout of a normal wolf net on a typical normal paper, and you can use something like a baking sheet, or this could also be tracing paper. You do not need the fancy or transparency film. You can use it. To be honest, I find very difficult to work with that because that doesn't give you a true transparency, and you still have to put it in the back, and then you have to lift it up constantly to draw anything. So it doesn't work well, to be honest, at least for me. So I just like to use this type of paper, or you could use another one of this quality of paper, and that is transparent enough to for you to be able to do the question. So if you remember, the first step in this just becomes that we put the transparency or the baking sheet right on top of our wolf net, and then we take the center, and then we take a thumbtack and then push it down into a hard surface. So all now it will do is that it can rotate freely. All right. Now I'm gonna quickly run through the first component, which was draw the stereographic projection, the part A. And this is something that we have done previously, and you can just follow along and maybe practice and sort of time yourself. It is important to time yourself on these wolfnet questions, because you might not have done enough example problems of those type, and you're still learning these. So you want to make sure that it doesn't consume up way too much time than you have in your final exam, because this is a type of question that will take a decent chunk of time. Right, so you can notice that this is coming out. All right, so I'm just drawing the outline Right, so the outline is done. Now I'm gonna draw all the axes, so the north south, and then the east west. Whenever you're doing any wolfnet question, just make sure that all the movements are rotation and then bring it back to, and this helps you, marking these axes helps you bring it back to the set position. So something like this. All right. So I'm going to quickly do all the projections, all the poles. So this over here is this is a 100. The center was given as a 010 standard projection, which means the one coming from outside is y-axis, the one going at the top is x-axis, so on the right will be the z-axis. So the east will simply be 001, the west will be the opposite of that, so negative z, the south over here will be negative x, and then now I'll do, so these are all the 4-fold 100 family of poles. I'll do the 2-fold now, so 10, 20, 30, 40, and then 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45. Right, and then same on the outside, 10, 20, 30, 40, 45, 10, 20, 30, 40, sorry, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45. Alright, so let's quickly label them as the vector sum. This will be bar 101, this will be 101, this will be 10 bar 1, and this will be bar 10 bar 1, and then this will be bar 110, this will be 011, this will be 01 bar 1, this will be 110. Right, so these are all the two-fold poles, and if you remember, the next step is to draw a line that joins all these outermost poles. And if you want to be really accurate, you could just rotate this and draw along this sort of axis to get an accurate, and then same thing. Alright, now once we have done this, now we'll draw the great circle corresponding to these two, or you could pick these two as well. They'll all be at the same point, but since they are already on the east-west axis, it is a lot easier for us to draw the great circle. Before I start drawing the great circle, make sure everything is aligned with the wolfnet, and then you can draw the great circle over here. And I'm not completely going all the way to the south, but this should be good enough for now. All we got to find is the intersection point with these diagonals. So once we have found those intersection points, we can mark them as the 111 poles. Alright, so this, for example, will be 111, this will be bar 111, this over here will be bar 11 bar 1, and how I'm calculating these, I'm doing a vector sum of the center and the outside, and then this will be 1 1 bar 1. Alright, so we have the entire stereographic projection. So if you didn't time yourself, I would still recommend doing this from the scratch and timing yourself and making sure you're comfortable with drawing this in a really quick manner. Alright, so now let's proceed to the trace, which was the actual question that we want to solve. So to draw the trace, we want to draw the trace of bar 111. So let's see, where is that pole. So bar 111 is right over here. So let's call it A. So we'll take this pole A, and then as the step says, to get the pole on the horizontal axis or the east-west axis. So let's rotate, and now keep in mind to not rotate the wolfnet, it is, I recommend just keeping the wolfnet stable and rotating your tracing paper. So we'll take this pole A, bar 111, and get this on the east-west axis, which is right over here, the horizontal axis. Now the next step is to count 90 degrees. Now if you remember, we can count the 90 degrees by in either this direction or this direction. If you count in this direction, what it does is that you'll have to come back and continue from here. So it'll be the same thing. So we'll just count in this direction because we have easy space. So let's see. So this is at this second point. So we have 2, 12. The 2 comes from this 2 degrees. So 2 degrees, 12, 22, 32, 42, 52, 62, 72, 82, 92. All right. So this was 92. So we'll just mark it right over here. It'll be sort of somewhere in between, but just from a rough drawing. All right, so this is the trace of bar 111, which was the point A. So again, what did I do? So this was my initial projection. The question is calculate the trace of this pole, bar 111. Step A, get the pole on the horizontal axis of the wolfnet in the back. Step B, count 90 degrees. So wherever this is located, count 90 degrees from there on. We calculated the 2, this might even be 3 or 4 degrees over here, so be careful with that. But as a 2, this entire thing is 10, so this much, this angle till here becomes 12, 22, 32, 42, 52, 62, 72, 82, and then 84, 86, 88, and 90. And then we picked that great circle which was at the 90, and then we drew that entire thing. Now this pole A is at 90 degree to any point on this entire trace. And so for example, I'll give you a quick example. Let's say I ask you to calculate, let's call it the point C. I ask you to calculate the angle between point C, or the pole C, and the pole A. All right. How you do that? You just get them on the same great circle, if you remember that from our previous question. And let's see. So let's get point A and C on the same great circle, probably somewhere right around here. And then let's calculate. So this will be 2, 4, 6, about 6. So 16, 26, 36, 46, 56, 66, 76, 86, 88, and 90. So you can see C and A are at 90 degrees. I could pick this point as well, this pole. Let's call it pole D. Now this pole is also at 90 degrees from the pole A. Let's see that real quick. So let's find a common great circle for pole D and A. So somewhere about here. All right. So this is about 6 degrees. Yes. This is about 8 degrees. So 2, 4, 6, 8. So 8, 18, 28, 38, 48, 58, 68, 78, 88, and then 90. Alright, so you can see that when we drew the pole, or when we drew the trace of A, so this was A, we drew the trace, any point on this entire trace is at 90 degrees. Right, let's try another one. So let's try 101. So maybe you can take a pause on the video and try this yourself. The steps will be, if you have to draw the trace of 101, get that pole on the horizontal axis of the wolfnet which is behind, count 90 degrees, mark the great circle. That great circle is the trace. So we have to do it for 101. So first identify where is 101. So I can see the 101 right over here. Let's call it the pole B. Alright. Alright, so let's do the step 1. We get the pole B on the horizontal axis of the wolfnet. So this is the pole B on the horizontal axis. The step 2 is counting 90 degrees. So let's count 90 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Alright, so this line itself, which is marked already, is the trace of 101. And I'm just going to highlight it again, and then I'm going to just make an arrow and write trace of 101. Make sense? And this any point on this entire line is at 90 degree with 101. So this is how you can draw trace of any pole I think, yeah. And then, yeah, and this is how you can draw the trace of any pole on the stereographic projection. I'll just quickly repeat the steps. Get the respective pole on the horizontal axis, count 90 degrees, and mark that great circle. And we had pole A, bar 111, pole B, 101, and then this great circle became the trace of A, and this great circle became the trace of B. Alright, now let's quickly check out the next question, because it follows along the same pathway. Now someone asks you to calculate the zone axis of, it could be any two poles. I just chose these two poles for simplicity because we already marked the traces. But let's say there are two poles for which you have to calculate the zone axis. The steps associated with those is that mark the traces of both the poles. So pole A and pole B, mark their traces on the net, and the intersection point is the zone axis. So let's see. So we had pole A, bar 111, we marked its trace, it's this great circle. Then we had the pole B, 101, we marked its great circle, this line. And now we got to find the intersection. So this point over here is the intersection. And this intersection is the, here, I'll put an arrow and just write it here. This is the zone axis of bar 111 and 101. Now, why did I draw it in this manner? So any point that, so if you remember that stereographic, the way stereographic projections are made, if you have this sphere, you had this equator, there's a cube sitting in the center of this equator. Now, if I have a plane, I take its projection up, connected to the south point, this is the pole, and same on any other side, this is the pole. But if I take that same plane and take it downwards and then connect it to the north point, it will have the same location, however we represent it with an open circle. So a closed circle and an open circle. So because the zone axis can be either pointing up, which is outwards from this plane, or inwards into the plane. And then this is the zone axis. Now a question is, what is the zone axis? What is the HKL or UVW notation for this? To calculate that, you need to do a little bit of math and simply do cross product. So let me show you that cross product real quick. And this is something you can do analytically first and then locate that on the stereo net. So that would just be IJK, and then we'll write the bar 111, 101. So I'm just doing the simple cross product. And this will just become 1 minus 0 minus j minus 1 minus 1, and then plus k 0 minus 1. And if you don't know the cross product, you can Google it. There are many easy ways to do cross product on the internet. They have example problems, but I just did a cross product, and this will just result in 1 dot I, and then this will be minus 2, so that will become plus 2j, and then minus k. So the notation would be 1, 2, bar 1. So the trace over here is just 1, 2, bar 1. That is this point right over here. And that is, this is the zone axis. Zone axis of bar 111 and 101. So this example sort of used all the things that we have learned till now. The first step, we made the stereographic projection. Next step, we wanted to make the trace, we had to count 90 degrees. So we counted angle between points or poles. And then we marked the trace of pole A by taking it to the horizontal east-west axis, counting 90 degrees, marking the great circle. We did the same thing with the B, getting it on the horizontal axis, counted 90 degrees, marking this line that was the trace of the B. And then to find the zone axis, we found the intersection of the two traces. That was zone axis of bar 111 and 101. And then we did this analytical cross product of the two poles to get the notation for the zone axis. And then we wrote that in here. So with this problem, you should be able to solve almost all the questions, and I'll do another example problem that will cover all the things that we have learned.